Hi, this is a beginner C++ game tutorial designed to be as easy and accessible as possible. This video is targeted towards those that have learned the basics of programming and are looking to apply what they've learned to making video games. Specifically, we're going to learn how to make Pong using a game library called Raylib. Game libraries let us interact with the hardware, allowing us to do things like draw graphics to the screen, receive user input, and produce sounds. There are many libraries to choose from, some alternatives being SDL, SFML, or Allegro, but I chose Raylib because it's the easiest to use and get up and running. It's also low level enough that we'll be able to make all the important game functionality without relying on an existing engine or framework. Because I'm assuming you might be very new to programming, I'm going to go through the full installation of everything we're going to need, including our IDE, Visual Studio, Raylib, and Git, which is required for how we'll install Raylib. Feel free to skip any part you don't need, and without further ado, let's make Pong. So one of the trickier things when you're first starting out programming is actually not to do with the code itself, but getting the code up and running. So how we compile the code, where do we write the code, things like that. So what we're going to be using in this tutorial is software called Visual Studio. Visual Studio is an IDE, or in other words, a place we can program where it helps us with the programming. And Visual Studio is the perfect solution for C++ development on Windows that way. So the first thing we're going to have to download, we're going to have to download a couple things here. But the very first thing we have to download is our IDE, Visual Studio. So to download it, we're just going to come down here. You can see there are 3 versions. We just want Community. That's the free version of Visual Studio. So if we click that, it's going to bring us to the download. And there it is. So I can click on that and start up the installer. Now I have completely uninstalled Visual Studio and all the stuff we're going to be downloading, so I should be seeing the same thing you guys are seeing. Okay, so here we are inside of the installer. Now notice this is the installer. It's not Visual Studio itself. We basically have to install the installer, and then the installer installs Visual Studio. Yes. So now, once you're in the installer, this is version 2022, by the way. We want desktop development with C++. This is the package that we're going to want to install with it. So you can keep the default values here. I'm going to make it so that we don't have to worry about anything. Just stick with the defaults. One thing you might want to change is the location. If you're comfortable with using the file explorer and things like that, I'm going to change my location right now. So I just created 2 folders for the Visual Studio IDE and the cache in my D drive. Now notice you cannot change the location of some of the stuff we're downloading. It has to be in your C drive, in your system drive. But once you're done, we can go ahead and install. And it's going to take some time to download now, or install rather. Okay, so now Visual Studio 2022 is up and loaded, so now we can start writing some code. So what we're going to do is we're going to create a new project. We're going to choose empty project. Alright, and then we're going to press next, and let's give it a name. I do not want it in the C user, so I'm going to change that. Okay, so I put it in my virtual E drive under tutorials, and I'm going to simply call it Pong tutorial. You can just call it Pong if you'd like. Okay, let's create. Okay, so this is where we are in Visual Studio. One thing I like to do is I like to have the Solution Explorer on the left side, so I'm just going to change that immediately. And so let's add a main.cpp file to our solution, or in other words, our project. So that we can actually have an entry point to our game. So very first, we're just going to press add new item. And we're simply going to add a C++ file. I'm going to call it main.cpp. Okay, and this should show up in our project directory, which we had made before, and add. Okay, so we have main.cpp. Let's just add a main function here. return 0. Ooh, there's some settings I'm going to have to change. And if we try debugging right now, it brings up this console window showing us that our program did run successfully. If we want to do something a little bit more interesting, we could add a hello world, so we can. So let's see if this is going to compile correctly. And there it is, hello world. Perfect. So that's all well and good, but we don't want to just use strings, right? We're making games. We want to have a window, we want to have graphics and all of that. We're not making console games anymore. So, how do we get graphics into our game? Well, we're going to be using a library called Raylib. Raylib, as you can see, is a simple and easy to use library to enjoy video games programming, and that could not be more accurate. It is very easy to use, yet still powerful and low level. So we can really start from scratch using this. Now, in order to use Raylib, what we'll have to do in Visual Studio is, all we have to do is include a file. As a matter of fact, you know what, I'm going to get rid of this. Let's get rid of this as well. We're just going to include raylib.h. Now, as you can see, though, we cannot open the source file raylib.h. And that's because it doesn't know where to find this file. You might not even have it on your computer. So how are we going to get that onto our computer? Well, Raylib has a very easy way to access it using something called VC package, which is available on Windows. Basically, all you have to do is run this. You have to run these commands in a command prompt, and you pretty much have it installed. That's all you have to do. Write this stuff. Now, we do need one thing, though, and that is git. If you want to use this git clone command right here, you have to use this. So let's just download this quickly. We're going to download git. All we have to do is come to git at cm.com, downloads, and we are on Windows. And as you can see, I already downloaded it a couple times, but this is a new installation. Yes. So you can see I put the git folder in my libraries folder in the E drive, and now I'm going to click next. I'm just going to keep it as default settings, and that is basically all I'm going to do for this entire thing. This is actually pretty long, so let me just click next, next, and here we go. Alright, and so we can say finish. You don't have to select either of these. Now we have git installed. So, we're actually getting really close now to getting Raylib in here. So all we have to do, like I said, oh, by the way, we're not clicking this download button. This is how we're going to download Raylib, so you don't have to worry about that. So all we have to do now is write these commands. Now, where do we write these commands is the question. Well, you're going to do it in a command line. So if you're on, so you can just open up a command line like this and type in the commands, but I have another way to do it. If you don't have immediate access to this command window, we're going to go into Visual Studio, and Visual Studio has its own command line or terminal. So if I go to View and I go down to Terminal here, the PowerShell is going to be brought up, and I'm going to type those commands into here. Okay, so now those commands are git. Actually, before we do it, we should probably make sure that we actually did download git. So let's just type git and then enter. Okay, so one thing I forgot about is that if we actually want to make use of git, we actually have to refresh Visual Studio because we installed git after opening Visual Studio. So let's just refresh Visual Studio, X out of it, and go back in. Okay, and here we go. I'm back inside. Now we can type git, and as you can see, something pops up saying this is all the ways you can use git. All right, perfect. All right, so next, let's type in those commands that are on the GitHub website for Raylib. The first command is git clone https://github.com/microsoft/vcpackage.git. So if you type this correctly, it's going to clone VC package. All right, perfect. And next we're going to cd VC package. Perfect. And now the // bootstrap VC package.sh. Perfect. VC package integrate install. And now this is the main thing. This is what's going to allow it so that whatever we install into VC package is going to apply to our Visual Studio. So let's integrate that, and you can see applied user ride integration for this VC package root. And last step is VC package install Raylib. Oh, sorry, I forgot the // or no, // VC package install Raylib. Okay, so I guess you have to do that for some reason. You can't, in this PowerShell terminal, you can't just say VC package. You have to / VC package. But anyway, yes, now it's going to extract and give us Raylib, basically. Okay, and the total elapsed time was 39 seconds. Wow. And it has downloaded Raylib. So now, if you notice, we have installed Raylib. We have set up VC package and integrated it with Visual Studio, but we still do not include that simply because, just like with Git, we have to refresh Visual Studio. So let me do that. Okay, and now I am back in Visual Studio, and now there's no red squiggly line under include Raylib. If we run this empty program, here we go, no errors or anything like that. So now, finally, we can get started coding some games in Raylib. Okay, I made the font bigger so you could actually see what I'm typing, and we're ready to get started. So, the first things first that we have to do is actually create a window, because this window that pops up when we press the debug button, that's just the console window, not an application window. So to make the application window, we're just going to call the Raylib function init window, and we have to give it a width, a height, and a title. I'm going to make mine 800 by 600, and the name is going to be just Pong. Okay, and whenever we create something, we also have to destroy it. Otherwise, we're going to have a memory leak, or it's also just good practice. So, we're going to close window at the very end of our program. Everything else is going to be written in between. Now, there are some flags that we could set to customize the window we created, but we'll get to those a little later. Anyway, let's see what happens when we create this window. Okay, so as you can see, it created the window. It flashed up for just a second there, less than a second there, but it went away. That's because we're not doing anything. We just opened the window and then we closed it immediately. So what we want to do is add a game loop so that we can keep the window open for its entire lifetime. The way we make the game loop is we are just going to say while, use a normal while loop, and say while not window should close. So while the window shouldn't close, meaning we're doing stuff with our game, it's going to continue running through the loop. Now window should close will break out of the loop when we either press the X button right over here, or we press a key to exit out of the window. Now, as you can notice, I actually cannot click the X button right now. The entire application is just kind of stalled. That's because the X button doesn't work automatically. Windows doesn't make that work automatically. We have to make it work. So let's continue writing the code so that we can do that. Now, to do that, we're going to use a function called endDrawing. But before we call endDrawing, we probably want to call begin drawing. Okay, so that's going to start the rendering process, and then we're going to use a clear background function so that we can color the background of our window. I'm going to make it black because we're going to use black for the game. And then we can call end drawing. Now the end drawing function does more than just end like the whole drawing process. It also pulls some events. An event being anything that we do with the application. So for example, if we want to press this X button up here, that's an event. And end drawing is the function that handles these events for us. Oops. And as you can see, we drew the window all black, and we can X out of that now. Just a fair warning, if you write the code with just end drawing, or you forget to add begin drawing and the clear background function, you're going to get a flashing effect on the window, and that might be bad for some of you. So always make sure you have begin drawing, some kind of clear background, and then end drawing. Next, let's draw the FPS. Raylib has a very nifty draw FPS function, which is going to draw us, it's going to show the FPS for us. Okay, and I'm just going to put it 1010. I'll explain what 10 and 10 are in a moment. But let's see what happens if I run it now. Okay, so now you can see we have the FPS in the corner, and it's constantly changing. Now you can see it's running very fast. It's running like 4,000 frames per second. So what I'm going to do is I'm going to enable a VSync flag. That's going to make it so that the game only updates as fast as our refresh rate. So if the way I can set a flag for the window is I'm going to use the function set window state, and then I'm going to add flag. And if it doesn't pop up here, you should see enums. You can click this plus sign, and then more options are going to show up. So I want this flag VSync hint. Okay? And if we run it now, you can see it starts to settle around 144, which is the refresh rate of my monitor. It could be 60, it could even be 30. But whatever your refresh rate is, it's going to try to stay at that number. Okay, so the next thing we have to do is start drawing not just the FPS, but other objects in our game. The Pong ball, the paddles, and we're going to use that obviously using circle and rectangles. But in order to draw, we have to understand one thing. So let's look at this draw FPS function. Notice if I hover over it, it takes two arguments, the position X and the position Y. So X and Y are just like the Cartesian coordinate system that you learn in math class, in algebra. X is where you are horizontally and Y is where you are vertically. The only difference is, as you can see, I put in 10 and 10 and it showed up in the top left. That's because 0, 0, X of 0 and Y of 0 actually corresponds to the top left of our screen. So because it's in the top left, as X gets bigger, right, if I were to say 100X, it's going to go to the right, just like in our normal Cartesian grid. But if I do 100Y, instead of going up, since we're already at the top, bigger numbers go down. So when we draw, we have to keep in mind that the origin is in the top left, and Y goes down as the numbers get bigger. So I'm going to put these back at 10. So let's start off by drawing the circle, our ball. So we're going to do that by typing draw circle. And we have to write the center X and center Y of the circle. That's going to be right smack in the middle of the screen. So to get the middle of the screen, we want half of the width. So normally we could do it just by typing the number 400, which is half of 800. But I'm going to go a slightly different route. I'm going to actually get the width of the screen and then divide that by 2. Because that's what we're actually doing. We're not just putting a random number 400 there. We're actually deriving it from the width of the screen. And I'm going to do the same thing with the height. And the radius is just going to be 5. It's not derived from anything, so I'll just leave 5 there. And I'm going to make the color white. Okay, and let's see what happens. Yep, so we have a white circle right in the middle of the screen. Very good. Next thing is we're going to draw the left paddle rectangle and then the right paddle rectangle. So, where should the left rectangle be on the X? Well, we just want it to be a little offset from the left. So I'm going to put mine at 50, an X value of 50. Y is going to be a little more tricky because if we try to just do the same thing as the circle, get screen height divided by 2, and let me just fill in the rest so that we can draw the thing. I'm going to make the width 10. I'm going to make the height 100, and obviously a white color. So let's see what happens now. Alright, so you can see that the rectangle is not centered in the screen like the circle is. That's because the circle draws from the center, whereas the rectangle, just like the screen, draws from the top left. So when we set the Y value to half the screen size, the top left goes to half the screen size. So to fix that, we have to subtract half of the height. If we subtract half of the height, then it's going to move the paddle up exactly, well, half of the height, which is going to put us at the center here. All right, so that's good. Next, we're going to draw rectangle, the right rectangle. And now to draw the right rectangle, this is also going to be a little tricky. We want to get the whole screen width, right? And we want to subtract 50 from that. That's because we want to, if we're drawing the left paddle 50 from the left side, we want to draw the right paddle 50 from the right side. However, because it draws from the left side and not the center of the paddle, we're also going to have to subtract the width of the paddle. That will make it so that the left side, or the right side of the right paddle, is 50 away from the width of the screen, whereas the left paddle is, the left side of the left paddle is 50 from the screen. Okay? And position Y is going to be the same thing as the previous one. Divide by 2 minus 50, half of the height. And then 10 for the width, 100 for the height. And white. All right, and if we run it, there we go. We got it perfect. Everything's all lined up literally perfect. So now we've drawn our objects, but here's the thing. They're only ever drawn in one position, right? No matter what I do in the game, the circle is always going to be drawn in the center, and the rectangles are always going to be drawn at these numbers. If we actually want to move them around, we're going to have to replace these constants with variables so that we can change what the values are. So to do that, I'm going to create some variables up here. They're going to be of type float because they're going to, they don't always have to be integers. So I'm going to say float ball x. I'm going to start with the ball. And I'm just going to write the variables out first, ball y. And you know what, let's also do one for the radius. Float, you know what, the radius can be let's make the radius float. Float ball radius. Okay, and what I'm going to do now is I'm going to replace each of these arguments with the variable and set the variable equal to whatever I set here. So, oops. So ball x is initially going to be get screen width divided by 2. Ball y is going to initially be get screen height divided by 2. And the radius is just going to be 5. And now we replace each of these with the variables. Ball x ball y, and ball radius. All right. Now, if you look down here, you are going to get some conversion errors here. Not errors, but warnings. That's because these variables are of type float, whereas the function takes ints. And actually, it does take a float for ball radius, so that's fine. What's this one then? Oh, these are getting. So what we can do, this is actually an int because getScreenWidth gives us an int. So let's just divide by a float so that it becomes a float. And we're just going to add int here. So we cast to an int. Okay. So now that we have our ball has new variables for their position, we're going to start moving the ball around. So I'm going to do this before we start drawing, right? Normally when you have a game loop, you do all the updates first and then you leave the drawing for later. So right here, I'm going to update the X and the Y of the ball. The way we're going to do that initially is we're just going to take the ball X and add some speed to it. So we could just say ball X plus equals 1 at first. So we're going to say ball X plus equals 1 and ball Y plus equals 1. Now that should already get the ball rolling. Here we go. It's moving off the screen right there. Now there is one thing we want to do, and that is we want to actually multiply our speed by the frame time, because perhaps on your computer, if you don't have a 144 hertz monitor, this ball might actually be moving slower. That's because if the frame rate is faster, the game is going to run faster, and this is going to happen more times in a second. So to change that, what we have to do is multiply by getFrameTime. This is going to get the amount of time between frames, and the smaller the frame time is, meaning the faster the FPS is, then this is going to be a smaller number. And if the frame time is smaller, it's going to be a bigger number. So basically, it's going to make up for that difference between frame rates between monitors. Okay? And now if we run it, it's going to move very, very slow. You can see it's only moving like a pixel every second or so. That's because getFrameTime is a very small number, and we multiplied it by 1, so it's only going to be a very small number when we move the ball. So instead of multiplying by just 1, we want to multiply it by a bigger number. But before we do that, I'm actually going to replace these constants once again with variables. That's because we're going to be changing the speed of the ball as we start programming more parts of the game. So let's create a ball speed X variable, and we're going to set it equal to, I think, 300 might be fine. And then we're going to make a ball speed Y variable, also 300. And we're going to replace the ones with ball speed X and ball speed Y. There we go. Now it's moving at a more reasonable speed. Okay, and next, let's add some logic to this ball, because right now it's just going off the screen immediately. We want it to bounce off the tops and bottoms of the screen. So how are we going to do that? Well, we're going to have to use a condition, right? We have to check if the ball is going off the screen. We're going to reverse its direction or its speed. So I'm going to write if, and the way we're going to check if the ball is going off the top of the screen is ball Y is greater than get screen height. Because if the y is greater than the height of the screen, that means it's going off screen. So we're going to want to reverse the speed. So we're going to take ball speed y, multiply that by -1. That is going to reverse the speed and go back up. Just like that. Now let's see if I can, now there is a bug here. I'm going to see if I can get it. I guess not. Sometimes you can get stuck, and that's because if the speed of, remember that the frame time, it can vary. The time between frames can vary, which means sometimes you're going to go off the screen at a big number of get frame time, and other times you're going to get a small number of get frame time. Basically what this means is that you can get stuck at the bottom of the screen for a little bit. So to stop that from happening, when we hit the bottom, we're going to set ball y equal to screen height. And now there's no way that the ball can get stuck at the bottom of the screen. And now, aside from the bottom of the screen, we're also going to handle the top of the screen. So if ball y is less than 0, then we're going to set ball y equal to 0, and then reverse the speed of the ball. And now if we, I'm going to lower the speed x so that we can see it bounce off the top and the bottom. Boop. Boop. And it goes off the screen. Very nice, very nice. Alright, and I believe that is all for the movement of the ball so far. I'll keep the 100 there. Now, the next thing we're going to do is we have all of these we have all these variables related to the ball, but they're all kind of distinct and separate from each other. What we would like to do is have all of these variables in one place. And also, if we keep all the variables in one place, it's going to allow this draw call to be also in that same place and use the variables better. That probably doesn't make much sense right now, but once you see the struct that we'll be making, it probably will. So what we're going to do is make a struct called ball. A struct is just a collection of variables and functions or methods. So what we're going to do is basically take all these ball x and ball variables and just put them inside of this ball struct. So I'm going to have float x and y. I'm going to have float speed x and speed y. And I'm also going to have float radius. Alright, and now all I'm going to do is I'm going to create a ball struct. So basically this is like an object. It's an object that contains all of these properties. And so instead of saying float ball x or float ball y or whatever, I'm just going to call the ball object and set the property of the ball, each property. Okay, and we're gonna have to do a little bit of refactoring by replacing all of this stuff down here as well, so let me do that. Okay, so I'm done refactoring all this, and all I have left is the draw circle call. Now, I'm actually not going to, I'm not going to keep this here. What I'm going to do is in this struct, we don't need just properties. We can also add functions to our struct, which are called methods in this case. So I'm going to create a draw function inside of the ball struct. And inside of that draw function, that's where I'm going to call this draw circle function. And notice, because these are all ball variables, but I'm inside of the ball object, all I have to do is reference the property name all by itself. I don't need to add the ball or ball dot or anything like that. I can just use the numbers or just the properties. Okay, and now if I want to actually draw the ball, down here instead of writing draw circle, I'm going to write ball dot draw. And that should continue to draw the ball just like we was doing before. Yes, very good. Now this refactoring may have seemed a little unnecessary or over the top, but I think for the paddles, it's going to make a little bit more sense because we have multiple paddles rather than just one ball for the ball structure. So let's go on to the next part. We are going to create the paddles now. So we're going to create the paddles. First of all, we want to create the paddle struct. We definitely don't want to create the variables and then have to refactor everything again. So for the paddle, we're going to have the same properties, x and y. We're also going to have a speed property, but only one speed property. We don't need a speed x and a speed y because it's only going to move in one direction or one axis. You could call it speed y if you want. I'm just going to call it speed. And we're also going to have floats for the width and the height of the we're going to have floats for the width and the height of the paddles. And also we're going to have a draw function, but we're going to save that for just a second here. Alright, so let's create the paddles now. We're going to have the left paddle, and the left paddle is going to have the properties that we have down here. So I'm just going to copy these. As a matter of fact, you know what? I'm going to collapse these. Maybe I can see them better. Not really. Or actually, yes, I can. Okay, good. So left paddle dot y equals this big thing. We're going to have left paddle dot width is going to be equal to 10. Left paddle dot height equals 100. And we're also going to have the speed. And I'm going to make the speed 500. I think that's going to be a good value. Okay. And so there's our left paddle. And we can make the right paddle now. We're going to follow very similarly to this. Now, I just noticed that we are going to change some of these because there's a change I want to make that's going to make handling the x and y and stuff a little easier. So for this draw rectangle function, just like with the ball, we're going to put it inside of the struct draw function. Except when we draw the rectangle, we're actually going to make x and y here the center of the rectangle. Now, how are we going to make x and y represent the center if we draw from the top left? Well, simply all we're going to do is when we draw the rectangle, we're going to offset the drawing by the width, half the width and half the height, which is going to put it in the top left. Let me show you what I mean. So assuming x is the center, I'm going to draw the rectangle from x minus half of the width. And we're going to do something similar with the y. And now that we're drawing the function at an offset, we can represent the x and y of the rectangle just using the center. Which means for these, for this right here, actually for the y, we don't have to offset by half the height anymore because the drawing function is doing that for us. And we also, for the right paddle, we don't need to subtract by 10 because the width is not being drawn from the left half anymore. So that simplifies our drawing, or our x and y's, just a little bit. Okay, and now all we're going to do, we're going to have left paddle dot draw, and right paddle dot draw. Okay. Looks like we have a little bug here. Let's find out what went wrong here. Oh, this should not be divided by 2. This should be get screen width. There we go. And as you can see, they're just perfectly aligned, even though we don't have those offsets anymore. Perfect. Okay, so why don't we actually get some gameplay going by starting to move the paddles. So, let me uncollapse these. To move the paddles, we're going to have to get keyboard input from our computer, or from the user. So to get keyboard input, it's actually very simple in Raylib. All we have to do is say if, and there's the function is key down. And that means the key is being held down, not that it's pressed. And we're going to use the, I'm going to use the WASD and arrow keys. So for the left paddle, it's going to be key W and S. So if I press the W key, that's what this is checking, I'm going to move the left paddle dot Y up. And remember, because Y gets bigger as it goes down, we're going to subtract to go up. And we're going to subtract by not just a number like we were doing earlier with the ball, but with the speed times get frame time. So we're going to do left paddle dot speed times get frame time. Okay, let's do the same thing for the downwards motion. And we're going to do the same thing for the right paddle, but using the up and down arrow keys. Okay, so now we should have the paddles moving up and down. And indeed we do. However, if we touch the ball, we do not bounce the ball off of the paddle. So, that is our next step. This is where a lot of the meat of the tutorial is going to come in, because we're checking for collision. Now, thankfully, we don't have to create our own collision routine, at least not in this tutorial, because Raylib comes with a small amount of collision functions that we can use to check if there's a collision between two things. So, to check if there's a collision, we're going to have to use an if statement. So we have to check if check collision between a circle and rectangle. So if checks collision circle rect, that is the function we're going to be using, and it takes 3 arguments. The first is the center of the circle, the second is the radius of the circle, and the third is a rectangle object representing the rectangle that is the paddles. Now this is going to introduce something a little new, and that is structs from Raylib. So you can see that the position, the center of the circle is not represented by an X and a Y, it's represented by a vector 2. All a vector 2 is it's a list of numbers, specifically a list of 2 numbers, hence the vector 2. So we're going to create a vector 2 object right here, and we're going to say the X is the ball.x, and the Y is the ball.y. That's the center of the circle. Then we're going to have ball.radius for the radius. And now for the rectangle, this is going to be a little bit tricky because we do have the rectangle that represents the paddle, but it's sort of hidden right now. So ideally we'd like to have rectangle, or here's what we could do. We could have rectangle, and then we would just define the bounds of the rectangle. So if X and Y is the center, well, first of all, to create a rectangle, the first property we need is the top left. The X value of the top left of the rectangle. So because our X is in the middle, what that would mean is we would need left paddle dot X minus left paddle dot width divided by 2. If you recall, that's pretty much how we got the drawing of the rectangle, right? X minus half the width. And if you notice, this right here actually defines the rectangle. This is the left of the top left, this is the top of the top left, and this is the width, and this is the height. That's all the 4 values we need to define the rectangle. So instead of writing it all here and creating a new rectangle, here's what I'm going to do instead. We're going to add one extra function here that's going to return to us a rectangle. And we're going to call it getRect. Yes, getRect. And what this is going to do is it's going to return a rectangle that represents the size of the paddle. And as we just explained, that is all of this stuff right here. So let's copy all of this and paste it right in here. So now this is going to return the rectangle that represents our paddle. Now we could also keep this in the draw rectangle function, but I'm going to do something a little bit clever. Not that clever, but kind of clever. I'm going to use a variation of the draw rectangle function called draw rectangle rec. And what draw rectangle rec takes as an argument is a rectangle object. So instead of listing out all of the parameters again, I can just call getRect within here, and that's going to return to us the rectangle that we needed. All right, and we keep the color. And now if we come back down to the collision, all we have to do, type left paddle, because we're checking the left paddle first, getRect. And that's going to give us the rectangle. You can see there are no errors. And what I'm going to check now is I'm going to bounce the ball. So to bounce the ball, all I'm going to do is ball.speedx times equals -1. You know what? I'm just going to check the right paddle real quick because the ball doesn't move to the left. So let's try to get the ball. There it goes. It bounces off of the right paddle. So we know that this check collision is working. That's great. You know what? We're going to copy this. Let's do it for the left paddle also. So all we got to do is change right paddle.getRect to left paddle. And now, if we up the speed of the ball, we should be able to get a playable game right now. Yep, there it goes. And so it actually goes back and forth between the paddles. Now there is a bug here. If I hit it on the left side, you can see it started to kind of drag down the paddle. That's because even though we changed the direction, after it changes direction, it's still touching the paddle, and so it's going to reverse direction again, and then reverse direction, back and forth and back and forth. So to fix that, all we're going to do is add a second check, and for the you know what, let me just switch these around. I want the left to be first and the right to be second. So if it's touching the left paddle, that means the velocity of the ball, or the speed of the ball, should be going to the left. Which is, going to the left means that the x speed is a negative number. So if we check if ball.speedx is less than 0, meaning ball.speedx is negative, that means it's going to the left, and so that's when we want to reverse the ball, speed of the ball. So if it reverses and it becomes positive, it's not going to pass this if statement. Okay, and then for the right paddle, we're going to check if the opposite is true. So now if we hit the ball on the sides of the paddle, it should work just fine. One more time. Perfect. Okay. So we actually have a playable game going now. We do have some we do have some, like, we have to have a win state, because if it goes past, then we're just kind of stuck here without a ball. So we're going to have a win state and a restart state. But before we do that, we should probably make this game a little more fun. Because, as it stands right now, all the ball does is go back and forth, and it's very predictable, the movement of the ball. It also doesn't get any faster, so it kind of stays the same difficulty throughout the whole game. You could basically play forever if you wanted. So to fix that, let's change some of the ways the ball bounces. The first simple change I'm going to make is, instead of reversing the speed of the ball just by -1, I'm going to add a little bit extra. Multiplying by this -1.1f is going to make the ball speed up just a little bit each time. So if I play now for a little while, the ball should eventually speed up. Yep, I think I see it going. Yep, here it goes. Now it's starting to get a little bit harder. Except if it goes too fast, then it starts just going horizontal. Oop, but I missed. So that made the speed of the ball go a little faster, but as you can see at the end there, it starts going just horizontally. So we have to change the speed y of the ball as well. And the way we're going to change the speed y of the ball is we're going to make it so it does two things. One, if it hits the top of the ball, it's going to bounce up, or the top of the paddle, it's going to bounce up. And if it hits the bottom of the paddle, it's going to bounce down. So to do that, there's an easy way to get this direction, relatively easy. So this is going to be a lot of math, by the way. Not a lot, but more than we've been doing this tutorial. So let's follow along. First things first, we're going to get the difference between the ball's y and the paddle's y. What that'll do is, if the y is higher than the left paddle, that means it's less, so this is going to be negative. And this negative speed is going to move up. So if ball y is less than left paddle dot y, that means the ball is at the top of the paddle, and the subtracting means its speed is going to be negative, which means it's going to bounce off the top of the paddle. So that's perfect. But if we run this as it is right now, it's probably going to have a strange effect on the ball. Okay, not too strange, but as you can see, it doesn't move the ball all that much in that direction, but it does make it move down or up as we want. The reason for that is because the ball has to be a speed of a couple hundreds, and the height of the paddle is only 100 itself. So what we have to do is we want to normalize the speed of the ball and then multiply it by a big number. By normalize, I mean we're going to divide by left paddle dot height divided by 2. So this is basically going to give us a range of values between -1 and +1. That's because the highest the ball could possibly be, if it's touching the paddle, is half the height of the paddle. So basically we're just normalizing the value between -1 and +1. Now that we did that, all we're going to do is multiply by a big number so that we can make the speed go, instead of -1 to +1, -500 to +500, for example. And we could just put a constant here like 300, but if we do that, as a matter of fact, let's check this out. I'm going to copy this down here and change it for the right paddle also, so that it does the behavior on both paddles. Oop, I missed. Alright, so now you can see that the ball is actually moving pretty interestingly now. However, because we made the y speed a constant, oops, it's going to be a little hard to show if I don't mess up. As we get faster and faster, we're going to see the same effect of the ball just going horizontally, because the y speed can't catch up to the x speed of the ball. Okay. So as you can see, it's starting to happen right now. The ball is just going horizontally. Oop. So what I'm going to do to make it actually bounce, to scale with the speed x of the ball, is I'm actually just going to multiply by the speed x of the ball. Okay, so instead of 300, we're going to multiply by speed x. And that is going to make it so that as speed x gets faster, oops, the speed y is also going to get faster. Oh, how did I miss that? Okay, so let's try to show it off now. Oh, looks like we're going to have to fix something here because it's going in the opposite direction on the right paddle. Okay, so as you can see, you can tell a little bit that it is going faster. So let's see here. Why is it being reversed? Oh, okay. Yes, because we're multiplying by ball.speed x. And when it's going to the left, ball.speed x, or after we reverse the speed, ball.speed x is positive on the left side, but on the right side, after we reverse the speed, ball.speed x is negative, which means it's going to reverse the speed y of the ball. It's going to reverse this part. All we have to do to fix that is just negate this. Negate the speed x of the ball so that it's back to positive. So let's try one more time. Nope, just got there in time. And now you can see, oh, there we go. Very interesting. I like this design, I'm not going to lie. It's very simple, but it works. So now I think we're on to the last part of this tutorial, which is to get a win state going. Get a win state going, show the winner, and then have a way to play the game again. So all we're going to do for that, first of all, we're going to have a string here, which is going to be the winner text. Okay, so this is going to be if the winner is, if there's a winner, then it's going to show the winner text. I'm going to initialize it to null pointer because it's an empty pointer at the originally. And next, I'm going to say, well, who is the winner? The winner is if the ball goes off the left or right sides of the screen. So all the way at the bottom here, I'm going to write if ball.x is less than 0. So if the ball goes off the left side of the screen, that means the winner is the right player. So I'm going to set winner text equal to right player wins. And if it goes off the right side of the screen, that means the left player wins. Get screen width. Get screen width. Winner text equals left player wins. Okay. Now I do not have a way to draw this text yet. So it is going to become, if it does go off the sides, winner text is going to change to those, but it's not going to change. It's not going to change yet. So what we have to do is we're going to, in the draw function, we're going to say if winner text. So if there is a winner, meaning winner text is not null pointer, then we're going to draw text winner text. Let's just put it at 100. You know what? Maybe 200 for right now. So that's the x position of the left side of the text. Now we need the y position of the top side of the text, which is going to be get screen height divided by 2 minus 30. I'm choosing 30 because my font size is going to be 60, and I do believe the height of the font is in pixels for 60. And then let's make the color yellow. Okay, so let's check it out now. Let's play a game and see who wins. Oh, right player wins. And as you can see, I chose a random number for the X value, so it's not really on center. So let's fix that right now. That's just going to be one last bit of math for us to do. So in order to get the center, we're going to make it just like with the rectangle. We're going to get half of the screen and then subtract by the width of the text. Now, how do we get the width of the text? Well, thankfully, with Raylib, once again, there is a function for that. We can say measure text, and we can provide it the winner text value, and then also the font size, and it'll give us the width of the text. So what we can do, so we're going to say get screen width divided by 2 minus text width divided by 2. Okay. And now it should be centered no matter who wins. So if left side wins, it looks centered to me. And if the right side wins, looks centered to me. And now only one last step to go. We have to make it so that we can press a key and then we restart the game. So I'm going to do that right here. All we're going to do is we're going to say if there is a winner. So we're going to check if winner text is not null pointer again. So if winner text is there, and if the key, I'm going to choose space. If key space is pressed, then we're going to reset the game. So to reset the game, we're going to put ball.x at get screen width divided by 2. Get ball.y equals get screen height divided by 2. And we're going to get ball.speedx. I think we set it to 300 at the beginning. Yep. Equals 300. Ball.speedy equals 300. And we're also going to set the winner text back to null pointer. Okay. And let's check it out now. So if I press space right now, it's not going to reset the game because the game is still going. But once I lose, right player wins, and I press space, we can start up a new game. And let's see who wins this final round of Pong. Oh, left player, WASD. Very good, very good. Okay, and that is, I believe, all of the code that we need for some version of Pong. Obviously, there are different things we could do. We could keep score instead of just, winning once somebody loses or somebody gets a point. We could also make it, we also did not add that there are no bounds for the paddles, so they can actually just go off screen. That I'm going to leave as an exercise for you, the viewer. And potentially there are other things we could change. Plenty of other things. One thing I like to do a lot is make the ball curve once it hits the paddles, so that it makes it a little more dynamic. But for the basics, that is all we have to do for Pong. First of all, congratulations for making it this far into the video and finishing our game of Pong. To wrap up, let's review some of the things we learned in this process. So in this tutorial, you learned how to create a window and set up a basic game loop. Now admittedly, this step was very Raylib specific. In other libraries, it's actually quite a bit longer and a little bit more difficult to do. But Raylib made this in a few lines of code. Next, we learned how to draw shapes using screen coordinates. That's the coordinates that start in the top left and go to the right and down. And we also applied algebraic techniques to make those calculations easier. That's like when we took get screen width and subtracted 50 from it so that we could get it on the right side as far as it was on the left side. We made things move by supplying the draw routines with variable values. So instead of just hard coding constants like we did at the beginning, we replaced them with variables, and we were able to move our drawings with that. We also used get frame time to account for different frame rates or different monitors, which if VSync is applied. We learned how to clamp the position of things and reverse their direction of motion. That was when we reversed the speed by negating it. We had to make a speed variable for that, and we clamped the position with an if statement. We utilized structs to simplify and organize the code, especially when it came to those paddles. And also the draw routines, having them condensed within the struct rather than having them random calls later in the game was helpful. We control player characters by handling input. That was a bit straightforward. And lastly, we used math and problem solving skills to design the dynamic gameplay. That is the ball bouncing off of the paddles. And these are all of the functions, enums, and structs, basically everything from Raylib that we used in this video. Now you might be wondering, how did I know, or how does one know about all of these functions, enums, everything to do with Raylib? Well, that's what I want to show you at the last little bit of this video. So what I have here is the Raylib cheat sheet. This is a page on the Raylib website. You can go to raylib.com and then go to cheat sheet right here. And this cheat sheet is a reference to all of the functions and all of the structs and enums in Raylib. So as you can see, it doesn't have the enums, but it does have colors and structs. The enums, you might have to look into the source code to find those. But anyway, as you can see, it's separated up into modules. We have the core modules here. This is our very specific stuff like creating a window, all of the flags, checking for all the flags for the window, some monitor settings. In case you have dual monitors, you can change which monitors to get the refresh rate. So this is all the core stuff, maybe some drawing and input related stuff. Yep, right here. And then we also have the shapes module, which is all of our draw functions. And now this is where you can have a lot of fun, because there's lots of different things we could draw. We can draw pixels, we can draw lines, we can draw line strips, which allow us to draw polygon outlines. And we also have draw triangle strips and triangle fans, which allow you to render polygons or draw polygon texture. I think that's in the next one. So these are all the draw functions we can use, as well as some collision detection functions like the check collision circle rect that we used. And we have a module for textures, we have a module for text, just text, models, which is used for 3D video games, and audio. And then beyond that, we have all the structs used in Raylib, some definitions for colors. And again, if you want to find the enums, sometimes you might just have to look into the source code. Or another way to learn about Raylib is by looking at these examples right here. If you click on one of these examples, like basic window, it's going to have the code for this program that's right above it. And as you can see, this is just a simple opening a window and making a game loop, just like we did at the beginning of our video. So that's all for this introduction to game programming, and also a bit of an introduction to Raylib. If you liked this video or found it helpful in any way, then you can consider liking and subscribing, as more videos like this are soon to come.